Hello, out there on YouTube, or good morning, good evening, good afternoon, depending on where you're watching or when you're watching, if you're watching. um, Either way, welcome to the stream. Um, so today I'm gonna work on this project here where during the last stream um, I did some work on the application here. Uh, I also did a bit of work after the last stream, but since I was pretty tired, I didn't stream any of it. But basically, we're at a point where we will have resources here. Let me see. Let me just order these views here. Um, we have resources that for each frame gets submitted to our renderer. Um, and um, yeah, I lost my train of thought, but trail of thought, I guess it's called. Anyway, um, so one problem I had during the last episode was that I was able to create these drawable meshes here, but they didn't have any transforms. So, whoops. Let me just see. Let me. I just need to check whether I messed up something on the stream. No, I did. Okay, let me lock this. Okay. So I decided that I, for one, inside the root signature, would create another parameter that we would just bind for now. We could eventually do a table with a bit of indirection. And inside the renderer, I initialized a upload heap based buffer. We'll probably change that, but for the constant buffers, which is needed to upload our transforms, which I've also created a system for outside in the resource manager. So we create some transform matrices here for the objects themselves. We just use some translations right now. No rotations, but that would be fairly trivial to implement since we would just call different math functions and do matrix by matrix multiplications and then store it in the matrix itself. So right now it's not coupled to the GUI system, but yeah, as I've mentioned, it's somewhat trivial. Um, we might want to do the reverse if, yeah, or we could do, yeah, depending on how much memory we want to use, we could do different stuff. But anyway, we then submit it to the renderer by calling renderer, and we assign the transform index. Right now we use the actual transform index as a mapping into the constant buffer where we, for each matrix, actually copy over our information here. And then, of course, we register the draw call. But yeah, this is not a great way to do it. But yeah, that's what I'll be changing a bit during the first part of the stream here. So yeah, right now we have a buffer. We simply print how many buffers we can support with our current data structure. And as you can see, whenever we initialize, we right now have space for 256 constant buffers in a 64 kilobyte buffer. We could of course just expand this according to our needs. Right now we will use this as a basic quote-unquote page file um, of buffers. As yeah, like a sort of memory allocation on the GPU where we can uh, upload our constant buffer data to. Um, of course, we would want different buffers because right now, uh, let me see. Oh, wait a minute. This is for the past data. Never mind. Although this buffer here is not utilized very good because the basic alignment in Directx12 is actually 64 kilobytes, which is why I created the next buffer here with that explicit size, because yeah, that means that unless our pass data for each frame really extends up to 64 kilobytes, we're not really utilizing this buffer. But yeah, I digress. But yeah, so we could increase the underlying buffer here. It's just an arbitrary value. How we map into it depends on how we use the actual buffer and how we interpret the buffer. So we do mem copies right now, and as you can see here, we bind the buffer itself with whatever memory address we think is correct, meaning that uh, we could kind of like prefetch this and just multiply it by anyway, it's not something that we need to optimize right now, but since we bind each buffer and not a table of buffers, we map it on to the GPU virtual address and tell the draw call itself, or rather the shader itself, where to find the information in memory. Yeah, but my whole point was that this is somewhat inefficient. Right now, we copy our data for each drawable, each time one drawable gets submitted, and this is wasteful since nothing might change for each frame, which means unnecessary work on the CPU and GPU and the PCI lane. So therefore, I think we should look into a sort of a way to handle this. And I was contemplating it a bit. And basically, a table lookup should be fairly quick. I wanted to use the version control here on the matrices and perhaps combine it with a bit of a flag. So I was contemplating something like a transform matrix, universally unique ID consists of a kind of like table index or memory uh, index, a version, and of course a type, but we don't care about the type. We already know what type we're using right now. But perhaps we would want to store a simple flag. Uh, um, Perhaps we want a flag in terms of the transform here. We could do something like a flag where we determine whether it's dirty, uh, which means that it could proc a either a allocation of a buffer if it's dirty, or a update of a buffer uh, location if it's dirty. Um, um, we could also decouple the updating, creating of whatever. Yeah. We could also just add the flag to the drawables here. So if we change the mesh, if we change, yeah, whatever. Yeah, maybe this shouldn't actually contain any information about whether it's dirty. Maybe we want the drawables to be should be flagable as dirty, mesh, or transform has been changed. Then we will have a memory index and a version inside our UID. And then maybe our backend here will of course have our constant buffer page file, but it should probably also have a table of assigned buffers. Um, um, as to help us map into the buffer whenever something needs to be updated. So perhaps we want the thing here to make us able to flag a buffer here for updating. So um, um, and yeah, my idea was something like a sort of flag system. I'm not sure it's supposed to be called a flag system, where we can ask the backend to update that specific buffer. Otherwise, just assign it. Keep it. Um, and for frame buffering, that would allow us to update the next frame resource individually. by simply controlling which frame buffer we are currently using and which subset of buffers we are then updating. But so in order to look up in this table whenever we do this, I mean, first of all, we would know whether it was dirty. So it would be something along the logic of, just in pseudocode, if dirty, update the constant buffer. Otherwise, just assign. Hello, buddy. How are you doing? So we could um, right now I'm working on the new project. How about you? But perhaps we want a draw call as well. Right now we store the actual constant buffer. Maybe we just want the constant buffer address, actually. GPU virtual address. Maybe we just want that instead, actually. GPU virtual address. What is a GPU virtuals? Oh, that sounds great, man. Oh, it's a UVN64. So yeah, so maybe this should consist of the draw call. What do we want? What do we want? What do we want? We do want to be able to assign to do this. So when we assign a buffer, are you working on any particular project? Game or rendering or uh, So when we assign the constant buffer here, right now we're just copying over each for each object or instance of a draw call, but we want this to be able to bypass it since it's waste of so we want some kind of logic where if we look into the table, we will look for a transform with the index and the version that corresponds to whatever, and we want to assign that address. Perhaps we want the table to be coupling that with a draw call. So uh, draw call and then uh, transform index plus version. So that would be 32-bit plus, what did we do for now? Let's see, 8-bit. Could get bigger though, 8-bit slash 16-bit. Let's see, a max size 16-bit int unsigned. We could limit yeah, maybe we end up getting too constrained here. But we could store something like, anyway, maybe we just want 32-bit here. Individual draw calls per frame shouldn't surpass 3 billion or 4 billion or whatever. So whenever we look up this transform here, maybe we simply just yeah, maybe we don't want to store this actually. Let me just yeah, so we could keep a table on with 256 buffers right now. And then we could keep a table and let's say that table be updated with whatever uh, address where this is, or rather, we will grab the address itself, right? From the, well, we will get it from the table then, right? So our drawables come in. We do a lookup. We do a lookup in our table and ask, do we have a buffer with our transform index. And then we have a sort of branch. Yes. No. Assign that. Do we need to update? Let's see. Yes. Do it. Create the table entry. So, yeah. I think this will be faster than reassigning or updating the buffers constantly. Right now we will use the upload heap based one, but eventually you would want to update or upload the transforms to the default heap for more static resources. Therefore, you would want to differentiate which would need to be on the upload heap and which would need to be on the default heap and which would need constant updating, and yeah. But I think the thing is, the draw call itself uh, should store the virtual address for now, instead of the indices, because and then we would skip the whole computation stuff, and we would probably have pre-calculated the index and thereby almost the pointer into the virtual address space. So yeah. So whenever this loop gets started, this should actually be some kind of like a lookup into a table. Uh, do I can I find anything with the index and the version, and then assign it? We could do something like uh, update dirties first, where we iterate over each draw call with the dirty flag, or kind of like create a temporary buffer. Yeah. This should probably just be assignment. The index itself will be the actual iteration or whatever the count. So we will get that just from the table itself because they will be arranged. We could do something like that. Right now we won't support dirty variables, but or buffers, but I'm wondering whether because this won't work, this will break pretty soon whenever we allow to delete and well, it should probably break. And the whole point is that this takes 4 cycles on the CPU side. I don't know how many cycles it will take since it involves both the GPU and the CPU. So, and sending it over the PCI lane for potentially a lot of items, I think is a probably a more expensive process than actually just doing a lookup in a fairly small table. I mean, let's look at the L1 cache size just on this AMD total core. Let's see. Okay. Let's see. Is it per core? Let's see. Okay. 64 kilobytes. So actually, uh, a whole series of 256 transform matrices would actually fit inside our L1 cache, and therefore, right now at least, be fetchable. Let's see. Let's do a calculator. Yeah. So, uh, so we will have 8 bytes for instance for a table. Let's do that would be 2 kilobytes, so we would be nowhere near our L1 cache um, limit uh, in terms of looking up a simple table. Um, let's see. Uh, int compare cycles avx not simd actually. Uh, let's see. Let's see. Okay. Yeah, we'll try it. I mean, I'm unsure of the performance penalty compared to simply just copying everything over. Yeah, I won't know. Wouldn't know, but anyway, let's just build this system and um, a simple table lookup is not. Uh, uh, oh my god. Yeah, I don't know. Should probably be tested. Um, it's a fun problem to think about, but maybe I'm wasting a bit of time here. mem copy cycles. Okay, maybe I'm not supposed to do any hmm. Yeah, what's table lookup to avoid mem copy CPU? Uh, yeah, I would have to test it. So right now we store draw call index, uh, constant buffer. This is going to be the GPU virtual address. Okay. Each transform gets assigned a. Okay, I guess we could use a system where each kind of like CPU-sided transform has a corresponding underlying constant buffer um, on the GPU, and we could, whenever we kind of like make a transform go stale on the CPU side, we could kind of like perhaps flag that specific constant buffer and do some logic around when we assign new objects or create new objects, that we make sure that we pair the CPU side transform matrix to the constant buffer uh, um, matrix data entry. Yeah, maybe that's more elegant. Maybe I'm overcomplicating this by speculating in lookup tables. Yeah, I think I am. Okay. So for now, we will do a GPU virtual address. Okay, and this will of course need to change. Let's see. Buffer start. Get. There we go. Okay. There we go. Okay. Let's see, you went 64. Uh, 01. Okay, we have some bug here. Let's see. Okay, this. Let's see. Draw call. Yeah, and the transform index is 0. Great stuff. Oh well, yeah, of course. We need this to be size off. There we go. Whoops. No, 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 no. Or is it? Wait a minute. No, it's definitely not that. We could also do. Uh, a size T buffer size. There we go. Recalculate that. Of course. There we go. And we're back. we could move this out of the should probably be handled outside this loop, since we would like to update, create slash update separately eventually. Yeah, let's just forget about this for now. Okay, we will live with the temporary mem copy here for now. Okay, that was a lot of contemplating, doing absolutely nothing, but yeah. But I would like a small uint. Can I do 2 for 8? See, maybe a bool is a dirty false. Okay, let's do what we. I think this can be const, right? And this should be call drawables. If call dirty. False. Yeah, right now we aren't rendering anything, because whenever we create the whole thing, we want to make it dirty. True. True. There we go. So when we create or update, we flag it dirty, and therefore the whole thing runs. Let me see. Okay, several thousand frames still. Yeah, we would need performance testing and looking into where our bottlenecks are in terms of handling the resource allocation and stuff. Right now for this simple program here, we're fine just mirroring the CPU-sided memory in terms of the GPU-sided memory. This could eventually be differentiated into static buffers and dynamic buffers. Changes never versus changes often in terms of heap allocation and update method. Yeah, but right now we're using um the upload heap. Okay. Okay. So I guess this is now a system where we can update our transforms or drawable meshes. And we can do draw calls. Where we simply assign the draw call itself for each frame. We could skip this work here. By adding a flag, or rather a specifier on how many dirty things we want to update, and then simply skip this, but it's optimizations. Right now we will be fine doing that. Also, we could split it, meaning that we could prefetch if we had a lot of objects where we wanted to. I think this would probably a fairly small step in terms of how much work we would need to do. So maybe this should only. Either way, we would have to. Okay. Okay. Let's do it. So const unsigned int uh, 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 num alloc dirty, maybe just dirty, num dirty. Let's see, am I allowed to do this? Whoops. Whoops. If num dirty, we do this. And let's do a simple unsigned int num frame num dirty. Uh, let's see. And inside our application here. Resource manager. Mm. 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 Let's do a function here where we const unsigned int temp will be our frame num dirty. And then we will set our thing here to 0, return temp. So we will reset it every time we call it, which means that we inside our application here can ask the call resource manager to get the number of frames 30, and we can be sure that it resets. So of course we won't be doing anything right now. Let's see, missing default parameter. Oh, okay, I can't do that. Yeah, nothing of course happens because right now we're not doing anything. Instance frame num dirty plus plus, and there we go. So each time we updated the objects, we will simply. Is this actually proper? Yeah. Great stuff. So this won't be called unless we actually have dirty objects. Great stuff. Great stuff. Great stuff. Okay. I'm thinking that we might want to implement some basic shading here. Uh, Let's see. Okay. So inside our pixel shader here, we would probably want some kind of hard-coded directional light. So let's see. We had in our previous shader, we had something like this, compute directional light, where we need a light vector and the normal, of course, of the particular vertex or the interpolation of the normal between vertices for that specific pixel. And we need a light strength. Are we even using this mat? Okay, yeah, we're using the mat for the blend pong function here. Okay. And we need a Schleck Fresnel as well. We need a light material info. And then we need a light. And as we can see here, we need a direction and strength. We don't need the fall off start stuff. We don't need a position. Let's be explicit here in terms of what we actually want and need. Uh, and then we want a function where we return a light directional here, light, and we pass in a light material info. Let's see. We pass in a normal and a vector to the eye position. And we pass in a float shadow factor. And we simply set our result here to 0. And then, whoops. And then we return result plus equals our shadow factor times with our light here, our material, and our normal, and our I vector. Okay, so this basically couples everything. Let's set this, maybe this is the actual color spectrum, I think. Let's create a red light with a bit. Let's see. This shouldn't matter too much. A -1, and then so this will be kind of like a directional light where we shine a light that is not only going down but maybe at an angle here. So this will be our standard light. Okay. Inside our pixel shader here, we need to use the whole light stuff. Let's see. The material. Let's do a float 4, diffuse albedo, which we will for now just initialize as a total if reflection of the heart. The last one is the alpha. And let's do a global ambient, which will be perhaps something along the lines of this. Let's normalize whatever input normal we have, normalize it. So we get a unit vector. There we go. And then we, okay, we would actually want our pass data then to be able to, available to our pixel shader as well. So we need to change this. Can I combine the flags? Probably can't. Can you combine shader visibility flags DirectX 12? Okay, it seems like it's all or nothing, or rather all or one. Okay. Let's bind the constant buffer here. Okay. Because we would like a camera position. Actually, so in our application, let's see, we pass along the camera. XM vector. That's to pass a reference. Yeah. Okay, so we can get the position. We can look up the position here. Let me see. I'm doing it inside here. Camera position. Wait a minute. Okay, it's actually... Okay, let's do this then. Oh. There we go. Okay. So now we, of course, I don't think the shaders will compile, will they? I don't think so. No. Okay, well, what's the problem? Oh, it cannot have default values. Okay. Let's see, let's copy this for now. Let's see, let's just define a global light directional light. I can't define it global. Yes, I do. Global directional light. Let's see. Is this fine? No. Line. Somewhere I'm converting from a float whatever to a. Okay. Where am I doing that actually? Oh, wait a minute. Maybe I do want to. Let's see. Ah, there we go. The problem is this code here, right? Yeah, I think so. Yeah, of course, then I should. Well, this doesn't get called, right? Well, oh, I need to. No, whoops. Okay. Okay, let's see. To cam, world space, normalize the pass data, camera position, minus the input world space position. Since we have no materials, we will simply hard code this. We also need a float const shine, which will be 0.5 for now. Let's do a light material info here. Add. Let's see. diffuse albedo. Fresnel. Let's do a 0.1, 0.1, 0.1. And then the shine value here. Let's just do that for now. And do a float shadow factor. Float 4, directional light. Compute light. Global directional light. Mat. Input normal to cam. Shadow factor. Float 4 lit color equals ambient. Uh, and let's just return lit color. Okay. Okay, what is my mistake here? I don't get any specific error. Let's see. Let's return a float for 1, 1, 1. Okay. So whenever we so it's not the function calls themselves. It's probably something related to the return value here. Let's see, compute light. Let's see. For some reason, the shader program here crashes. H result. C++. Error codes, H result. Let's see. Create pipeline state, graphics pipeline. Let's see. Pipeline state. Let's see. 57. Is that the error code? Looks like it. One or more of the arguments is not valid. Alright. Graphics pipeline state arguments invalid. So let me see. Let's see, lit color that ambient. No, it's not that. Okay, so if we simply do something like a pre-initialized field here, it should be fine, right? Yeah. What if we do the ambient light here? Yeah, the ambient light is fine. Directional light? Okay. So the problem is inside the directional light. And yeah, so the shadow factor here. Is definitely Let's just do this for now. Let's see. Let's see inside our vertex shader here. We do calculate the yeah, so we have a problem inside our shader script here. Let's see. Am I passing in some wrong arguments? Compute light. Lighting material here. What is the problem? Oh, debugging HLSL is pretty rough. So this, of course, would work if we just returned this right. Pretty obviously, yeah. Okay. We are uploading our camera position, right? And of course we can't access. Let's see. Our camera should have a position, and we can get that position, and we store it in our pass data. Huh. Now that's peculiar. Let's try creating a temporary normal here. Float 3 temp normal. That doesn't change anything. let's do a float3 to cam. Okay, so it's the vector to the camera, probably. Okay. Yeah, of course, this ends up looking pretty weird, but okay, so there's a problem in terms of our calculation of the vector to the maybe it should. Oh, wait a minute. It shouldn't be the vertex. I think that will be pretty weird. Is it? It is. Okay, let's try opening render doc and see what our application here. Oh, it doesn't do anything because it crashes, of course. Okay, temporarily we will just initialize this as sort of a directional vector here. And we will see inside render doc what we actually upload to our GPU in terms of the pass data. Huh? So it crashes. Oh, maybe it's because we need to run the post build script here. Let's just do a new build here. There we go. I think render doc should have them copied. Yeah, there we go. And I captured a frame here. Let's see. And the past data stuff. Float 4x4. Float 4 maybe? So we should have a let's go this. Okay. Um, Okay. So, what on earth goes wrong in terms of our stuff here? Because, I mean, this does look like our, what do you call it, camera position, right? Yeah. So let me just look at this call here. Our pass data here. Uh, well, space should be. Why doesn't it work? Am I supposed to? Let's do something like this. Does it crash then? No? Uh, huh. Okay, let's try something else. Float tempvec. Um. Okay. So this doesn't work. Input world position minus this. That works fine. So it seems like the camera position here. Is it related to the padding or is it just not properly visible? It should be visible. We're not getting any kind of errors like that. Is it because we try to load a register? Maybe it is. Let's try changing that. XM float 3, camera position. That shouldn't matter. XM load. Store float. Temp data. Camera position. Let's see. Store float. Yeah, basically it takes the first slots here. What? Ambiguous? No. Shouldn't be. Great. Okay. Uh, nope. Okay, let's do it in debug mode because maybe I compile without the debug flags. Maybe that's the problem. Uh, let's see. No. If we change these in the ordering. No. There's something wrong with this. I mean, the register. Let's just do a float pad. Why on earth doesn't it tell me anything about? Okay, let's add that flag. weird. Invalid argument, create graphics, pipeline state. Oh, or what? No, 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 that's not it. That shouldn't be it. Am I storing something that is aligned, perhaps? Because maybe it's due to some underlying padding. No. Let's just test this. Of course. Debugging HLSL code. Directx. Okay, so it's basically only related to that constant buffer. Am I allowed to predefine it? Oh, I'm probably not. So line 15. Whoops. I did something wrong here, right? Yeah. Struct. What? Oh, I need a semicolon. Whoops. Float test weg. Oh, wait a minute. Okay. Uh, can I shader debugging? Let's see, shader debugging render doc. Mm. Let's see. Let's see. Can I debug it some way? Toolbar. Where do I find? Let's see, a shader here. Uh, let's see, shader. Let me see, maybe I need to build with some different flags here. Okay. Let's see. Yeah, let's enable this for now. Okay, and let's do a no. Let's see. go. Oh my god, how do I step through it? Uh, okay. Let's see. We need to compile some debug stuff here, I think. Let's see. Compile debug. Let's see, NVIDIA inside graphics probably doesn't work, but we'll try. Let's see, pixel shader. Okay. Whoops. Let's see, tempvic. Testvec is fine. Can I recompile with this instead? Compile succeeded, but it doesn't work whenever I use this one. That's pretty annoying. Still shut down. Okay. Uh, uh, let's see. Options, perhaps. Um, uh, uh, Let's see. Where would the let's see. Let's see. I need to figure out. Whoops. D3D compile, right? Save, debug. Blob. Debug information in the shaders. Should be actually included here. I mean, the code itself inside the shader compilation here. Let me just look up that function. Let's see. Uh, let's see, does it compile anything inside our output here? Doesn't seem like it. Debugging HSL DirectX12. Render doc. Let's see. Okay. Mesh. Okay. Okay, so we can do that. Shaders. How to. Where on earth do I? How on earth do I enable that? God damn it. Should I pre-initialize it perhaps? Is it that problem? No. No, no, it can't be that. For some reason it doesn't compile it, does it? No, it just skips it. Because yeah, it just skips that one. Can I actually? No, I probably can't. Let's try seeing if the other part of the thing is actually making us crash. Let's try doing this. It won't make any sense, but it still crashes us. Okay, so we definitely have a problem with the resource binding of sorts. Uh, is it because we already did this? No. Okay. Let's disable all this. Uh, oh, it's debug vision. No? What? Oh, I haven't recompiled the shader because I haven't recompiled the program. So That's why. Now it should crash. Inside my draw call. Is it a redefinition? Because I could do something like this and then maybe no. And it should be shader visible. I mean, uh, uh, maybe we need the volatile flag. No? Oh, wait a minute. Let's see. Oh my god. Okay. That's a weird bug. That's a really weird bug. Because this shouldn't affect. Oh my god. So I found the bug, but I don't know why it would do something like that. Finally, we found it, but maybe. Oh, maybe the flag itself. Let's see. This flag, all resources bound. Maybe. Let's see. Shader visibility, DirectX crash. Pixel. Let me see. Can I find an explanation anywhere? Uh, create pipeline. Shader visibility. DirectX 12. Create pipeline. Root descriptor. Okay, maybe I misunderstood the way of doing that. Okay. Binding here. Okay. Okay, I didn't know that the shader visibility thing here was for binding different types of different kind of buffers to different shaders. I thought it was sort of an optimization. Oh. Oh, maybe. Huh. Let's see. Let's play around with the compilation flags. If I skip this, can I then compile? No, I still can't compile. Okay. For some reason, it wants. This would, of course, make us get a compile error, right? I don't know. For some reason, this fixes it. I really don't know why. For some reason, for some reason. Root parameter, shader visibility, Directx12. Let's look up that. Not. Visibility. Okay. Anyway. I guess we figured that out. Anyway. So now we have some lighting. And we've created a, yeah, of course we need to update the shaders, but let's create a white light. Okay. And let's oh, the normals are probably inverted. Wait a minute. Okay. Okay, root signature, not that. The pipeline. Oh, true. Let's try that. Oops. Okay, false. And let's see. Let's try cranking up the ambient here. We of course need to update that. Okay. Doesn't seem that we're getting anywhere. Oh, wait a minute. It's related to the old code here. Yeah, the normals are pretty messed up, it seems. For some reason. I mean, the shading goes on. Yeah, this is definitely not correct. Okay, let me see. Let me just double check the shader code here. This is still pretty weird. Did this change anything? I think so, didn't it? Okay. Looks better. Let's play around with these values. Let's create a red light here. That is having a downward going direction. That seems about right, right? Right. Let's try swapping it for something like this. Well, we're not really getting the expected results, right? Uh, let's see. Maybe we don't want to. Oh, now we're getting somewhere, aren't we? Okay. Let's try swapping this then. No. The normals are all messed up. Uh, let's see. Blender. Let's try overriding something here. Uh, triangulate faces. Apply modifiers. Let's try that. Um, for some reason, let's try doing that instead. Swapping the uh, And if we swap the order, false. Let's see. I'm not sure. Let me just look at these shaders themselves here. Yeah. Okay. We are using the correct shader, but for some reason, the okay. Let's try doing that then. The normals are still messed up. It's simply just the what do you call it? -c. What does apply modifiers? Update legacy. Okay, maybe I should do normal computations. Uh, Blender normals. Wrong. Can I actually... Okay. Okay. So basically the normals are probably inverted. Let's see. Normal here. So it's using this one, which is one of the corners, of course. And then number 3. Okay, so some sort of thing on the y-axis. Let's see. Is the last component the normal? And the last component is yeah, normals. So we use the normal one here. Let's try swapping the y on this one. And we're, yeah, the normals are inverted. The normals are inverted, I think. Or at least, let's try adding this to, of course I need to swap this back. Nope. Negative normal.y. Okay, looks more like it. Okay, let's see. Okay, next test will be a light that shines on the negative x-axis, meaning, as far as I know, the positive x-axis is to the right, and the negative x-axis is to the left, meaning that the light should shine on the right side of whatever object we have. Let's make sure that this compiles. Which it doesn't. For some reason, this doesn't change anything. Now that is pretty weird, isn't it? That is pretty weird, isn't it? Huh. Let's just try reversing everything here. Huh. For some reason, it doesn't do anything in terms of, whoops. It doesn't change anything, which it should. Am I doing this wrong somewhere? Maybe the normals are messed up. Well, we know that the normals are messed up, but converting from left edit coordinate system to right. Maybe it's my um. Let's see. Let's change this. I mean, for some reason, Inside the directional light here, we do the dot product of the negative and then the normal, and we do whatever's greater. Whoops. We can't get the light to shine on the sides of these objects. I don't know why. Shaders, pixel shaders. Am I hard coding something? No, this shit is not updating, or what's wrong? So this should. I mean, okay. Is that due to our reflection? Or albedo being no? Our albedo should reflect white, so something's not updating at all. Did I hardcode any values anywhere? Nothing's changing. I mean, it's not supposed to behave this way. I mean, it does still compile, right? This should make it crash. Yeah. I'm hard coding something somewhere. I mean, nothing here suggests that it should stay red. I mean, nothing here suggests that it should keep on being red. I'm missing something. I'm missing something. Mm. I'm missing something, and I don't know what right now. Let's only light the objects by using the directional light. Okay. But why does it keep on being red? Did I not change that in this shader here? Pixels shader. Let's try swapping off, turning off the red. Doesn't change anything. Does this value even change anything? Does it even matter? No. It shouldn't be creating any light when the... If we turn off this, well, then nothing happens. Okay, if we turn on this then, nothing, nothing, okay. So only the first component of the diffuse albedo gets used. Maybe the way I assign my material here is wrong. Huh? Maybe the autocomplete here is messed up. Okay. Let's edit the shaders again, pixel shader, and run the application. So here we got our new setup. Okay. Let's just check whether we actually get an updated camera position, because we should, right? So does our past data buffer here get updated correctly? I'm pretty sure it's not that issue. Yeah, everything gets done fine. Okay. So yeah. Okay. Inside my code here, I'll temporarily do something like this. Okay. Okay, right now we could be fine. No. No ambient lighting here. No ambient lighting. This is pretty weird. Um, I mean, Am I swapping the components? Is that why this is not working? I don't hope that's the problem because I'm really wasting time. Why is it only available in that view? Oh my god, the blend state here. I think I might have swapped the components. Oh my god. Okay, oh my god, I'm so stupid. Okay. And this is supposed to be going forward, which is actually correct. I don't know why this one, maybe the other one. Whoops. Let's try overriding whatever we have. There's definitely a problem of sorts here. What happens if I inside the... Okay. So it feels like I know we changed two things now, but okay. For some reason it thinks that the whole thing is yeah, I think there's an error somewhere in the lighting algorithm because or maybe well, yeah, I definitely think there's a problem with this lighting algorithm here because let's do something like 0.9 here and see if it changes. Yeah, because it's not supposed to simply light whatever is on the yeah. Do we normalize it? Yeah, whoops. Let me see. Let's see our Huh. Now this is pretty weird, isn't it? Let's see, inside the vertex shader here. Huh? Um, oh, we shouldn't transform it, of course. There we go. Ah, great stuff. I forgot that we don't translate the normals, of course. And then it won't make any sense. Okay. Lesson learned, lesson learned, lesson learned. Oh my god, I'm so bad at this. We could also do something like flow 3 by 3. Simply do like this, and then simply do like this. There we go. Okay. All right, we're getting there. We're getting there. This took a while. This definitely took a while. Great stuff. Okay, we have basic lighting then. Okay, maybe I should do a break. Okay, are we sure we want to flip the normals here? Okay, let's try setting things as we want. Seems to be something, and this should be, yeah. And the C, negative C, should be, yeah. Great stuff. Everything seems to be working. Okay. And finally, okay. Great stuff. Okay, I'll contemplate what to do next. Um, uh, we should probably do some materials and textures whenever we created some logic for setting up the different components that we already have implemented. Yeah. Yeah, we should probably do that. Anyway, I'm gonna end the stream for now. I'll probably be back later. All right, everyone take care.